All right, hey guys, today we are going to be kind of putting everything together that we've been doing these past few weeks. So we're going to be writing some systems of equations, we're going to be solving and graphing. So we're putting everything together that we have been currently doing. You're going to need the packet from the sub, and you're also going to most likely want a calculator. All right, please make sure you are on task today. Remember, I can see if you are watching the Ed Puzzle. Okay, if you are not on task or if the sub lets me know that you are losing your free time during Encore this week, no excuse. Use your time today, please. All right, in your packet, we're actually going to start on problem number 2. Okay, so we'll come back to number 1 if we have time, but we're going to start on number 2. It says Carly has $30 to spend at the arcade, and each game costs her $2. Denver, he has $40 to spend, and every game he plays costs him $4. I want to know, after how many games are they going to have the same amount of money left? All right, so we're going to solve this 2 ways. We're going to solve it algebraically, like you learned yesterday, and we're going to solve it by graphing. Okay, so let's start with Carly, what we know about Carly. Okay, so the first thing it says, define your variables. Let X represent and let Y represent. Okay, so when I'm trying to figure this out, wherever it tells you like each game or if it's per, that's usually the X. So the X is going to represent the number of games. Okay, I need to know how many games she plays. And then I'm looking for how much money they're going to have left. That's the Y. So this would be their money, their total money. All right, right away, before I even do anything else, I'm going to come label that on my graph so I don't forget. So this is my X. I'm going to put this is the number of games. Here's the Y-axis, and that's the money. Okay, so let's go ahead and see if we can write an equation for Carly. Okay, so for her total money, I'll put Y equals. Okay, she starts with $30, so I'm going to put that plus 30 in the back. That's how much she starts with. Every game costs her $2. So it's $2 per game, but she's spending that money. So I'm going to write 2x. If she's spending it, it's like she's losing it. That's going to need to be negative because every game is costing her $2. So again, she starts with this 30 bucks, but then she's spending $2 per game. There's Carly's equation. So what do you think? Could you write one for Denver now if you read his? All right, so for Denver, I'm going to write Y equals. He started with $40, and every game cost him $4. So I'm going to put negative, because he's spending that money, negative 4x plus 40. Okay, so it says, let's solve this algebraically, and then let's check it by graphing. Okay, so we know how to do it both ways, and we're going to kind of put it together. So first thing, to solve it algebraically, you guys learned yesterday that you can take, when you have 2 equations, if this is their money, I want to know when it's going to be the same. I can take those 2 equations, because they both say Y equals, and I can set them equal to each other. So I want to know when Carly's money, here's her money, negative 2x plus 30, when does that equal Denver's money? And his money is given by negative 4x plus 40. All right, so we learned you can draw your line down and we can try to solve this. Okay, so we've done this lots this year and last year. So first thing, you want to get the x's on one side. I like to get rid of the smaller one. So I'm going to cancel out negative 4x by adding 4x to both sides. Okay, so over here it cancels. I end up with 2x plus 30 equals 40. All right, now you want to get the x by itself, so I want to get rid of that plus 30. So I'm going to subtract 30 from both sides. And I'm writing smaller so I can fit it, because I started out kind of big. I end up with 2x equals 10. Hopefully you know your last step, divide by 2. So it looks like x equals 5. Now remember, x was the number of games, and we have that up here. So that means after 5 games, it says they will have how much money left? Okay, well, again, I'm going to have to find a little space wherever you guys have room. I know I didn't leave you the best amount of space ever, so I apologize. If you want to know how much money they're going to have, let's go ahead and plug it in one of the equations. So I'm going to say, all right, well, for Carly, it's $2 per game, plus she started with 30. So if they play 5 games, I'm going to plug in a 5. I'm going to do negative 2 times 5 plus 30. Well, 5 games, she's going to spend $10 plus that 30. She would have $20 left. Okay, now hopefully that's the same for Denver. I'll do Denver as well. So his was negative $4 a game. He played 5 games, plus he started with 40. Well, negative 4 times 5 is negative 20 plus 40 ends up with 20. So I know I did it correct. They both have $20 left. All right, now we are going to check this by graphing. Okay, so down on the bottom, I'm going to do my number of games. Okay, I'll start with 0 in the corner. You guys can kind of decide if you want to just do every line. I'm just going to do every line. So I'm going to do 1, 2, 3, 4, 5, 6, 7. I'll just go up to 7 games. Okay, now let's kind of look about what we're going to have to count by for the money. We have to get up to 40. Okay, so I'm thinking that I'm going to be able to count by 2s maybe. So I'll just do every line is 2. To save some space, you can say, okay, the first line's 2, here's 4, 6, 8, 10, 12, 14, 16. So I'm still counting by 2s. I'm just not labeling every number because otherwise there's not enough space. So the next line's 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. Okay, so getting up to 40 is high enough. Again, every line is really worth 2. I just didn't label every single one because it's kind of hard to write all of them, but you could have labeled every one. Okay, let's start with Carly's graph. Okay, so here's Carly's equation. Negative 2x plus 30. So this is good review. This is my y-intercept, so start at 30. Well, 30 is right here on the graph. I just made a black dot. The slope is negative 2, or negative 2 over 1. So that means I go down 2 over 1, down 2 over 1. Now, just be careful. Going down 2, I counted by 2s. So I'm really just going to go down a spot and then over a spot, because that is down 2, right? Because I counted by 2s. Okay, so I'm going to kind of keep doing that pattern. Okay, I'm going to just keep going for a little bit. Okay, perfect. Now let's do Denver's. Okay, I'm going to choose a different color for Denver's. I'll do blue. He started at $40, so way up here. Now his is down 4. Okay, now remember I counted by 2s, so if I go down 4, it's really going to be 2 spots. Down 2, 4, over 1. Okay, now look at where I just did it in blue. So down 4 was really down 2 spots. So I'm going to go down 2 over 1, down 2 over 1, then cross, yeah, down 2 over 1, down 2 over 1. Oop, just got across. I'll do a couple more. Down 2 over 1. Okay, now if this is number of games, I can't have half games, so I'm just going to draw this dashed. Okay, same thing for my black one. I'll just draw that dash too. Okay, and my crossing point appears to be right here. And I'll just list the coordinates. It looks like it crosses at 5, 20, which is what I got when I solved it algebraically. So my answer is 5, 20. After 5 games, they will both have $20 left. Now this was kind of cool. We solved it graphing, which we already had learned how to do. We solved it algebraically, and we could kind of check that it's right. Now you guys can probably see that solving it algebraically is a little bit quicker, which is why we have showed you this way. But you can still solve it by graphing as well. All right, let's go to the next page. We're going to go to number 4. So if you guys can find number 4 on the inside, and we're going to solve this one together. It says Neil is raising pumpkins to enter in a contest to try to grow the heaviest pumpkin. His best pumpkin currently weighs 22 pounds and grows at a rate of 2.5 pounds per week. Okay, that part's important. Per week, that kind of tells us what the X is going to be. Harry planted his pumpkins a little bit later. His best pumpkin weighs 10 pounds, and he expects it to grow 4 pounds per week. Okay. It says, write and solve a system to see, well, after how many weeks are their pumpkins going to weigh the same amount? All right, so first thing, okay, a little hint for the X. The X is always like the per, like, you know, per hour or per week, per day. Okay, and this obviously says per weeks, so X is the number of weeks. So I want to know after how many weeks are they going to weigh the same, so then Y would probably be their weight, because that's what I'm trying to find. All right, why don't you guys go ahead and pause the video and try to write both equations. All right, so for Neil, if you guys kind of look at it, I'm going to write Y equals, so to find his weight, it already weighs 22 pounds, so I'll put plus 22, and it's growing 2.5 pounds per week, so I'm going to put 2.5x plus 22, so 2.5 pounds per week. Harry, so to find his pumpkin's weight, it already weighs 10 pounds, and it grows 4 pounds per week, so I'll put 4 pounds per week with the X. Okay, now this one, we're not going to do it by graphing. We're just going to solve it algebraically. So I want to know when their weights are going to be the same. So here's, if I'm just kind of looking at it, here's Neil's weight, right? If you start with the 22 plus that 2.5, and then Harry's, You start with the 10 and add that 4x. I want to know when they're going to be equal, so I'm going to say 2.5x plus 22. When does that equal the 4x plus 10? So when are their weights equal? All right, now I'm going to solve this. Okay, so if you guys can go ahead and start solving this, you can kind of go ahead of me if you want. I'm going to subtract 2.5 x's from both sides. Remember, you want to get the x's kind of by themselves. I end up with 22 equals, if I do 4 times 2 or minus 2.5, I get 1.5x plus 10. Okay, my next step, get that x by itself. I'll subtract 10 from both sides. Okay, I get 1.5x equals 12. Okay, one more step, divide by 1.5. And I end up with x equals 8. Okay, so again, x was the number of weeks. So my solution is going to be after 8 weeks, both pumpkins weigh, well, to figure that out, now it's kind of like I do a check. So I'm going to come to Harry's equation. I'll do y equals 4. After 8 weeks, I'll plug in 8 plus 10. Well, 4 times 8 is 32 plus 10 is 42 pounds. So I think they'll weigh 42 pounds, but I'm going to do a check on Neil's. Same thing, I'm going to do 2.5 times 8 weeks plus 22, and hopefully that equals 42 pounds. So I'll quick check that, 2.5 times 8, and then plus 22, and guess what? It does equal 42. So I know I did that one correctly. All right, now that you saw a couple, I'm going to give you a chance to try some. So if you go to problem number 6, I'm going to help you kind of get set up on this one because this is going to be part of your homework. So I'll just kind of get you set up at least on this, and then you can get going. So 2 clubs at school are raising money for field trips. The math club started out with $20 and raises $10 every week. Okay, and then I also have the art club saves $5 per week and started with $50. So when are the 2 clubs going to have the same amount of money, and how much money is that going to be? Okay, so real quick, the X, remember that's usually the per, like if it's days, weeks, seconds. Okay, well this one says every weeks. So this is going to be number of weeks. Okay, the Y, what else am I dealing with? I want to know when they're going to have the same amount of money saved. So that's going to be the total money that they have in their accounts. Okay, so right away you guys should label that on your graph. X and Y, the weeks, and the money. Okay, then you can go ahead and pause the video and try to write the equation for both clubs real quick. Push play when you got it. All right, so for the math club, they started with $20 and they raised $10 a week, $10 per week. The science club, they started with $50 and they raised $5 per week. Okay, so I'm going to let you do part C on your own. I just want to I want to help you set up your graph. So for weeks, I'm just going to kind of count by ones down here. So that should be definitely fine for you guys to kind of pause the video, count by ones. I'll just go up to 12 weeks. For the money, you guys can see I have to, at least get up to 50, even probably higher than that. So I kind of always look at my numbers to decide what to count by. I have 10s, I have 20, I have 5 and 50. So a number that goes into all of them is 5s. So I'm going to count by 5s each time. So 5, 10, 15, 20. Okay, so you guys can go ahead and label those. If you don't like putting a number on every line, you can like skip a line. That's 45. Here's 50, 55, 60, 65, 70. 85, 90, 95, 100. I'll just kind of keep going. 105, 110. Okay, so you're going to finish this problem off then. You're going to graph it to see where they cross, and then you're going to set them equal to each other and solve it algebraically. Okay, once you get that one done, you are also going to do number 7. Okay, and if you are stuck on any of these, please go on the class kick because I can help you with these. So you're going to do, your homework is number 6 and number 7. And then if you go to the back page, these are all review problems. So if you look at the back, 8 through 13, you are also going to solve 8 through 13. Now, quick little refresher before you get going on these back ones. Like this first one, you guys should know how to graph. Number 8, the y-intercept, the slope. Number 9, just be careful. The second equation, you're going to have to rewrite. So I'll just give you a little hint. It looks like this to start with. You want to draw your line down and you want to get the y by itself. So you're going to have to move the 3x to the other side. You guys should remember doing this. Now I have y equals, and then you just rearrange that. Put your x first, plus 2. Now I can graph that. So now I know my y-intercept is 2. My slope is up 3 over 1, up 3 over 1. Okay, so number 10 looks pretty easy. Number 11 looks like you'll have to rewrite that one. Okay, when you get to 12, it wants to know if this is a solution to the system. Just a little hint. Solutions are x comma y. All you'll have to do is in both of these equations, wherever there's a y, plug in a 1. Wherever there's an x, plug in a 2, and then work it out, see if it's true. Same thing here. So plug in a 2, plug in a 1 there. Okay, when you get to number 13, same kind of thing. One of these points is the solution. So again, you'll have to, I'll just take off one wrong choice so you have a little bit less work to do. Wherever there's an x, you can plug in a 3. And wherever there's a y, you can plug in a 4 in both and then see if they work. If they don't, it's not a solution. Okay, so your homework then, again, is numbers 6 through 13 in the packet. Okay, you have the rest of the time to work. If you need help, please come in the class kick and put your hand up on a slide, and I can help you with one if you are getting stuck. I should be back tomorrow, so we are going to kind of keep doing some more of these problems. So have your packet ready for tomorrow because we're going to do a couple of the ones that we skipped as well.